This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay. Can you hear me okay, or mic doesn't sound like it's working at the moment, so. Hello. Hello. This doesn't sound like it's working to you guys, does it? No. Okay. Hello. 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 Yeah, it was muted in the central controls rather than the room controls. There's two controls for some bizarre reason. Okay, sorry about the delay. So, today, well, first of all, thank you for turning up. I know you've got projects and other things on. It's nicer for me to talk to at least a few of you than an empty lecture theatre. Today we're going to step back from some of the details that you've been going through. We've done all this UML modelling and design patterns and things like that. But we're going to step up a level and think about modelling and design in the overall software process. I'm not going to spend a lot of time on this, and I'm going to start by talking sort of generally about how it fits in, and then I'm going to talk about a case study just to give a different perspective on the role that design can play. Since we're, this topic is covered in a number of sections in the textbook, and I've put those sections up as reading on the LMS. They're very short sections, but they're sort of spread throughout the book. I like this quote in the context of this topic, and to illustrate why I like it, the quote being, "The best is the enemy of the good." I supervised a final year software engineering project quite some years ago, and there were two guys on the team with strong personalities, and they both had different designs that they wanted to use for their project, and they argued about these designs for about a week, and then I spoke to them after that, and I asked first one of them, do you think the other guy's design would work? Oh, it doesn't do this as, you know, no. Do you think it would work? Well, yeah, it would work. Okay, what about you? Do you think his design would work? Yeah, it would work. Okay, so you've wasted a week of development time. You've got 2 designs that would work. Isn't it better to choose one and actually get a system done than to actually spend more time arguing which is the best design? Obviously, you want to get a good design. You want a design that will work. But sometimes, as it says, the best is the enemy of the good. And if you try too hard to go for the best, you won't end up with something that's even good, that you won't even meet your deadlines, deliver a successful result. So I'm not discouraging you to aim high and go for something good, but you do have to understand the context of the problem and you know, take all the circumstances into account. And they did choose one. Of course, someone had to give in and let the other design go forward. So, as I said, we're going to talk about the design context here, and in order to do that, we need to be able to look at software engineering as a whole so that we can describe that context. And in order to do that, we're going to use the language of the unified process. So this slide has a whole lot of schedule-oriented terms that come from the unified process, and many of these will be familiar to you, and many of them get used and sometimes incorrectly used. And I'm not going to spend a whole lot of time going through these, but it's actually quite a useful reference to, as I said, terms you got blue circle again. Anyway, terms you will be familiar with, like milestone, release, increment, that kind of thing. Development cycle, iteration, phase, perhaps. But what I really want to focus your attention on is the 4 phases that are shown there. The first one is inception, and I'm going to talk a little bit about that phase, a little bit more in detail about that phase. And inception is really the stage of the project where you decide what is the project, why are we doing it? You know, have we defined what the project is it worth pursuing? And as I said, I'll go into that in more detail. The next phase is the elaboration phase, and that is the phase in which we try and minimise the risk of the project. So we're taking what we've decided in the first stage, in inception. We're now trying to minimise the risks of the project to make sure it's going to be successful, and we establish the architecture in that phase. So by the time we get to the end of the elaboration phase, we should know what our system architecture is. And then when we come to this construction phase, we're really filling in all of the capability of the system into a defined architecture. And this should be a minimal risk stage. So this is the stage, in a sense, probably with the activities you're most familiar with, where we're doing software development, integration and testing, and we're doing that cyclically in our context in an agile fashion. So we're going to iteratively build on the architecture to construct the whole system, and then finally we'll transition that system out for use by the user community. So that will involve things like beta testing, which is testing in the actual environment in which the system will be used, rollout, deployment, and training of both technical people and users, and all the other support activities. So this is our overall cycle here. All of these, other than inception, can have multiple iterations. Typically, we wouldn't have that with inception. It's one coherent activity, and we'll be trying to meet milestones at various stages. We'll be asking, should the project continue? So it's not a given. We'll talk about that with inception, but even at the end of elaboration, when we've put our architecture in place, or at some earlier point, we might decide that the project is going to cost too much, or there's some other reason why we don't want to continue with it. Typically, once you've put this in place, though you've eliminated the risks, you're less likely to stop for technical reasons during construction. But the business environment could change or something, so you might stop at any stage. Okay, so let's zoom in on this inception phase and have a look at that. Sorry, I've got a blue circle here again. Okay, so the inception phase is a phase where we're really trying to answer So we're trying to answer questions like, what is the vision and the business case for this project? The vision for a project is how will people operate differently in the presence of the result of our project? So our vision for how we're going to change the operation of our organisation, of the target users, whoever else, how will they act differently in the presence of our system? That's our vision, right? What's going to change as a result of the system? The business case for the project is how can we justify the cost and the resources we're going to put into this project, given the changes we're going to get, and also given the opportunity cost, right? It might be worthwhile spending the money on this project, but perhaps there's something even better we could spend the money on. That's what you're looking at with opportunity cost. You're taking away the opportunity to do other things by spending the money on this. So these are standard things you would do in a project. Making sure you have a clear idea of what effect the system's going to have and why it's of value. Obviously, you want the project to be feasible, and it might sound funny, but people set out on projects that turn out to be infeasible quite often. And sometimes that's because of time frame. You just can't build the system in that time frame. Sometimes it's because of technical challenges. But it's the combination of all the constraints. And unless you're willing to drop some constraints, it may be that the project is not feasible as a whole. We always have the question of how we're going to acquire this system, because we don't always build from scratch. Sometimes we buy a system, we acquire freeware. Sometimes we can't just use it off the shelf, we have to modify it. We have to at least configure it and go through all of those deployment activities to get it out to our users and so on. So it's never free, but we have choices here about how we're going to make this system available. We do have to consider cost. At some stage, we have to start considering the cost. At this early inception phase, we don't have enough information to get an accurate estimate, so we want a rough, not necessarily reliable range of cost. So 10K to 100K versus some number of millions of dollars. You need at least some sense of the cost of the project at this stage, but you certainly don't expect to have an accurate idea. So we're going to go through answering these questions, collecting information, which I'll come into in a little bit more detail, and then we're going to make a decision. Do we go ahead with this project or not, based on that information? If we do, we go ahead to the elaboration phase and start looking at what we need to do to put an architecture in place and so on. So fundamentally, what we're doing here as a whole is asking ourselves, do the stakeholders have basic agreement on the vision of the project? Because a common thing is that different people have a different idea of what should be done. And is it worth investing in serious investigation? So we're not talking about necessarily investing the whole $2 million that we roughly think it might cost at this stage, but do we think it's worthwhile going to the next stage, elaborating on our view of the project and starting to put a more accurate estimate in place, be clear about what the architecture is and all of those kinds of things. That's the question we're trying to address. So corresponding to that, as you would expect, as an outcome of this first stage, you're going to have this vision and basic scope for the project documented. You're going to have created this business case. In order to perform or answer the kinds of questions we've talked about, you're going to do some analysis of use cases. So you're actually going to try and enumerate all the use cases for your system as part of inception, but not necessarily all the detail. So if you remember, a use case reflects a goal for a particular user. So you're going to try and list all of the goals that someone might achieve in interacting with the system. And if you think about it, that ties directly back to the vision, right? How things are going to be different when the system is in place. Then what you're going to do is take that list of use cases and you're going to pick out the 10% of those use cases that you think are the most difficult or challenging, the most risky, the ones that are technically challenging, any of the things that are really going to strongly characterise the system. You're not going to pick the easy ones, right? You know you can implement those. When it comes down to it, you're going to pick out the ones that really drive the architecture, drive the risks in the project, and you're going to detail those use cases, write them out in full. You are going to also, at this stage, flowing on from that, look at what our critical non-functional requirements are. Is our system concerned with high performance? Is security an issue? Is data integrity an issue? What are the driving non-functional requirements for this system? Because they will impact on architecture, as we've discussed previously. If it looks like you're going to potentially move ahead, and particularly if the development of the system involves tools, languages, other things which you're not familiar with, that your developers haven't used previously, you might start preparing the development environment. So you'll download, install those tools, start to play around with them, get some experience, understand how easy or difficult they're going to be to use. So all of these things will happen. Something that may happen is you may start prototyping. You may actually start developing things that correspond to difficult parts of the system. So if you're concerned, if you have a critical non-functional requirement, which is performance, and you're using some new technology and you have some doubts about the performance, you might build a prototype to test the performance of that system, because this is about the feasibility of the project. Is it going to work? And then obviously you have your, based on all of this information, your go or no-go decision to move on to the next phase. It's worth noting, again, this quote from General Eisenhower: "In preparing for battle, I've always found that plans are useless, but planning indispensable." And really this quote is just a reminder that you do all of this preparation, but we're not trying to lock things down. We're not saying we're making a decision that we can never go back on, right? So you're doing the planning so that you have better understanding of what the risks are, what's going to work, what isn't, not to put down a plan and then say we can't vary from that plan. So it's really the planning that's valuable more than the plan itself. I mean, obviously it's a nice quote. You don't ignore your plan completely, but it really is the planning and the understanding you get from that that's valuable. And you'll see that in this inception phase, I haven't really talked about modelling at all, but we are enumerating our use cases and doing some analysis on a small percentage of them, and that's really the closest to UML and modelling that we do at this stage. I'll add one qualifier here on this next slide. So these are some of the artefacts you might produce at the inception stage of a project. The ones in italics, I don't know how easy they are to see from up here, but use case model, vision and business case, they're the ones that you would always produce. You should always have some representation of those as an outcome. The other things you may or may not have to some degree. You might start on them and then continue them in the elaboration phase. So you might have an early version of some of these other things. The one I was going to point out here is we've got a glossary, key domain terminology and data dictionary. Now I can ask you what part of UML corresponds to that. When we covered it, we talked about a visual dictionary, effectively. No takers? Well, use case diagrams we want, as we said, they're up there in the use case model. So you can have your diagram that shows all the use cases, and then you'll have your 10% which you've detailed. But the glossary here, the data dictionary, one way of representing some of that information is in your domain class diagram, your static domain model. So that shows terms and their relationships. So you might decide at this stage to start capturing, to start doing a static domain model, and then you might have details of the terms in your glossary or data dictionary somewhere, more information about the concepts than you would normally have on a UML diagram. So you could include that sort of data modelling as part of the glossary. So I'm not going to go through these in detail. Again, they're just there to give you an idea what it is we're talking about. Okay, so just to turn things around a little bit, you don't understand inception if. First thing, if you take more than a few weeks for inception. So this phase is intended to be a few weeks. It might be a little bit longer if it's a very complex project, but it's an investigation phase. It's one where you put this vision down. You're not trying to develop the system or put the architecture in place. We'll get to those things. It's a phase that gets to that decision point where you decide whether you want to invest more to understand the project better. You don't fully understand the project at the end of inception. If you've tried to define most of the requirements, like detail them, then you're not following this model. If you or your boss expects the estimates to be reliable or the plans to be reliable at this stage, then they don't understand what inception's about either. You don't have enough information to have reliable estimates at this stage. If you've defined the whole architecture, and let me be clear here, you would expect at the end of inception that you'll have some architectural concepts that you want to pursue. So you'll have some idea of what you expect the architecture to be, but the architecture is about a breakdown of components, defined interfaces, external components. You're not going to have all of those things sorted out at the end of inception, so you won't have a defined architecture. If you're following some sequence of work or planned out some sequence of work that involves requirements, design and implementation, obviously you're not following an agile model anyway, and you're certainly not working to the intent of inception. If you get to the end of inception and you don't have a business case or a vision, then you certainly haven't understood what you're supposed to be doing in inception, because these are key elements for everything that follows. If you wrote all the use cases in detail, then, well, you've probably wasted your time because you really only wanted those critical ones. You expect that use cases will change over time, so you've done a whole lot of work that you'll probably have to redo down the track as understanding changes, as the context of the project changes and so on. If you didn't write any of the use cases in detail, then you don't understand, because we're supposed to be trying to understand which are the critical and risky use cases at this stage. And if you haven't detailed them, how can you possibly know? So just a few guidelines, I guess, to follow there. So after inception, we move to the stage where we're now trying to deal with risks and put an architecture into place. And then we'll move through to our normal sort of development cycle once the architecture's in place. So two aspects that continue on through this whole process is what we call verification and validation. And they're two things that people often find very easy to get confused. So we talk about iteratively doing the right thing and doing the thing right. Validation is what we call doing the right thing. And what we're talking about here relates to requirements. How do we know we're building the right system? And in our agile processes, we go back to the client or the other stakeholders. So we're constantly seeking validation to make sure what we're building is the right thing. So we might document things, we might write use cases, but the information we got might change, the client might change their mind. We have to go back to the client and validate our understanding of the system. The other aspect of this verification is this question of, are we doing the thing right? So we're verifying that our design, for example, is going to support the requirements. Is it going to meet all those critical non-functional requirements? Is it going to support all of the functional requirements? Have we identified everything that's critical to the architecture? So we want to verify that what we're doing what we're developing at any point in time actually supports the system that we're trying to build. So we validate to make sure the requirements we're working to are right, and we verify to make sure we're building the system the right way. It's also worth noting a feature of Agile in general is this idea of provoking early change. We're not passively building stuff and hoping nothing will change. We're constantly trying to say, where are the risks here? What's going to be an issue for us? And if we need to change something, we want to change that as early as possible, not build a whole lot of stuff, then find we have to go back and change it. So we're not just passively embracing change, we're looking for things that we need to change along the way. The final note here is that as far as analysis and modelling goes here, we talked about use case writing and domain modelling as part of Inception, and we're talking about a few hours or days in this early stage. We're not talking about a whole lot of time spent on those activities. These few hours or days are mixed into those few weeks of Inception with potentially proof of concept development, finding resources, planning, setting up environments, all these other activities that go on. Another comment that I wanted to make that the textbook highlights, partly because I think sometimes students don't think about this particularly, or they'll think about it in a sort of rigid way, is that we can and often need to spread use cases across iterations. You can't necessarily implement the whole of a complex use case in a single iteration. Iterations in Agile are time-boxed, so you might be working 3 to 6 weeks for an iteration, and that's a rigid time frame. You don't choose a set of requirements and work until they're done. You choose a period, you select the scope for that period, time-boxed period, 3 weeks, 6 weeks, whatever it is. You choose work that will fit in that, and if you find you can't fit the work into that period, you scope the work down. You don't extend the period. That's a key feature. So it may be the case that we're doing a fairly complex use case like processing sales, and we will do some features of process sales in one iteration, and we might do something else like this is a feature logging which cuts across lots of aspects of our system. So we're going to implement that logging feature, an initial cut of process sale, and then in iteration 2 we're going to do further work on process sale. And we'll ultimately finish that off, and then we can combine that with starting on other use cases. And perhaps we'll do part of process sale. We could do, for example, nowadays you'd probably prioritise credit sales over cash sales, but you might start by doing credit sales and delay cash sales even till after you've done other use cases. So you might do sales on credit, rentals on credit, and then come back and do the cash versions later on. So you can break these up in different ways. You're not constrained to the structure of the use cases in how you pursue your iterations. Okay, so can't change slides again. This is only a problem I have in this lecture theatre. Okay, so how do developers design models? This is really, in a way, emphasising a point I made very early on, which I'm sure you won't remember, so that's why it's worthwhile emphasising it. What's really important about some of the modelling that we've talked about is the way you think about things more than the actual process you go through. Certainly, if you're dealing with complex, difficult things, going through the details of modelling, I think is really important. But sometimes thinking about things the way that you model them, thinking about patterns and so on, even if you're not being explicit about exactly what you're using and documenting and so on, is important. And in a way, I'm emphasising those same points from a different direction here. So how do developers design objects? Well, sometimes they just code, and there's nothing wrong with that. There's nothing wrong with sitting down and writing some code, particularly if what you're doing is pretty straightforward. So you'll design while you're coding in whatever language you're using. Ideally, you'll be using some kind of IDE. You'll have some kind of visual sense of what you're putting together and the relationships between things. You might generate a UML design diagram to make sure you're monitoring the complexity of what you're building and so on. You should have an idea of what patterns you're applying, but there's nothing wrong with going straight into coding as long as you're managing that complexity and thinking about it. But sometimes it's more appropriate to draw UML, whether you do that on a whiteboard with a case tool or whatever, and do some modelling quite explicitly, sometimes capturing those models. Sometimes there'll be things that you can just throw away, but doing that before you go on to coding. There are also tools that let you do the coding in the tool and generate a code framework from them. And I've certainly worked in organisations where we've used that. Some of those tools allow round tripping, where you can generate code, code templates, fill in the code templates, and then even if you modify the code template, the tool will update then the models to match the code. So you get this round trip. You can either model the design in the tool or modify the design in the code, and it will keep them in sync. So that's certainly a good way of working as well. Number 3 is only draw. Just draw models and so on. And ironically, I've been in IT for a long time, and even when I was an undergraduate, people were proposing tools where you could just draw rather than write code. And they haven't come into existence yet. And the reality is that even if you have a tool that you can draw a program, you're just going to be programming in a drawing tool. So as the quote here from the textbook says, many a dead tool vendor has washed onto the shores of this steep island. I remember have you heard of SAP? Very popular corporate information system development framework. SAP is German for System Analysis and Program Development. And I remember they were offering courses for SAP development where you didn't have to learn to program. They just trained you to do the development directly in SAP. How long was the course to do that? 6 months. So you could do a 6-month course to learn to not program in SAP, which involved filling in incredibly complex forms and so on through an interface, which basically had you programming through a kind of interface. So you can call it what you like, but ultimately at this stage, short of AI advancing a lot, programming is going to be around, I think, for quite a while longer. And again, just really a reminder here, modelling, typically a group activity. You want multiple sets of eyes, input from multiple people, review from multiple people. So it's something you do with other developers. We iterate between our static and dynamic models. So we have our class and interaction diagrams, and we expect that we'll make these models in parallel, right, and iterate between them, refine them as we go along. Certainly a lot of places I've worked at have lots and lots of whiteboard space for doing this. It's very common to work on whiteboards where everyone can see it and then use some kind of digital capture and only put things in tools if they're seen as valuable for the long term. But you can do it however you like, hand draw on paper, on a whiteboard, straight into a tool, whatever suits you. I've mentioned this previously about the round tripping and so on. If we're doing Agile and we're working with 3-week iterations, then we would expect that you're going to be doing some modelling of some sort, typically in UML, for a few hours to a day near the start of the iteration. So you would be deciding on the scope of the iteration, you'd be getting together with your other team members and making sure you understand what you're building for that iteration by modelling on a whiteboard. That's the typical way that we would operate working in an agile environment. Okay, final point I wanted to make. The whole point of this UML modelling is to reflect decision-making about the design. So I've mentioned this before, we model to understand and to communicate our decisions and alternatives. Those two things are what it's for. It's not because we have to, or it's required, or because I told you to. It's to improve your understanding and to communicate and explore choices. You should use correct notation simply because if you do, then people will understand it better. Certainly, particular development environments will have their own local variants or shortcuts or whatever. That's fine. Any new person who comes into that environment can be introduced to that, but primarily you want to stick to the correct notation. And the focus here really is on object design. It's not about UML drawing. The UML drawing is to support the object design. And object design, as I mentioned right at the beginning, it's about understanding the principles of responsibility assignment and being able to justify or explain your choices, typically in terms of design patterns or the basic principles. Okay. So that brings me to the end of our short kind of context. Now, as I said, I wanted to go on to talk about a case study to give you yet another perspective, I guess, on the role of design. So this is a case study I was involved in some years ago. So what's important for you to understand is that there were real people. This was someone's business, employing drivers and so on. You know, this system we're going to talk about was business critical for them. They couldn't operate without this system. So the issues that they had were really important to them. It's not just some hypothetical thing. It was, yes, people's livelihoods involved here. And in this case, this is a quote that I've chosen because certainly in my experience, as this quote says, "I've yet to see any problem, however complicated, which when you looked at it the right way, didn't become still more complicated." It's certainly the case that as you go through understanding these things, there are all these complexities that seem to kind of continuously come out. But obviously, ultimately, you tend to get on top of it and understand the complexity, and then you learn to deal with it. But it's very easy to kind of think you've got to the stage where now we understand and now we know what's going on, but usually there's a few more layers yet to work through. Okay, so let's have a look at this case study. The client in this case was a relatively small chauffeured car company. They had about 30 drivers, and they had a bookings and dispatch system, which, as I've mentioned to you, was business critical. So they took bookings by phone or email, mostly by phone, 1 to 4 operators working concurrently, and the operators would put the bookings into the system for the clients. I should mention that this company's model is not your sort of Uber-type model. Their clients were people who generally business people, executives and so on. They're not people who want to be looking at an app going, "Oh, there's my car, it's kind of going around there." They're people who want to walk out at 5 o'clock when they book the car and the car's there. That's their model. The car's not there at 5:01. It's actually there waiting at 5 o'clock. And that has some serious implications for the way that whole business is managed, to the degree of utilisation you can get out of the cars, and obviously to the cost as well. So they're not competing with Uber in that sense, though there is some element of competition there. But the way they distinguished themselves was by ensuring that that car's always there on time, no matter what. So it is a different business model. This business had been running for a long time, but they had some issues. The system that they were using was slow and would sometimes just hang completely. And if you've got a customer on the phone who's trying to give you a booking, that's incredibly embarrassing and difficult, and also bad for your business. And in some cases, because of this slowness or it hanging, or in addition to those things, they had these periods where the system was simply unavailable, they couldn't run it. And ultimately, they'd have to resort to paper and pen. They'd actually have to write bookings down and then later on come and enter them into the system. And that's error-prone, and you have issues then, particularly if the bookings are in the short term, if you can't get them in quickly enough. There are all kinds of flow-on issues there. The system had lots of missing functionality. For example, generating invoices, various forms of reporting. The accountant there would take a week to do something that should have been pretty simple and straightforward. Obviously, looking forward, the business knew what they needed was a customer portal where the customer could get online and make bookings, not ring up and send email and things like that. Certainly they wanted to move in that direction, and some of the other problems that they had made this move fairly difficult. They'd been using an IT provider who was just simply not helpful. They were, in my estimation, quite unprofessional because they didn't do the job of understanding the way the business operated. And I'll say more about this later, but they developed a new version of the system for them that instead of understanding the workflow the business had, combined things according to that put things up on a screen that were related in data terms rather than in business process terms. So if the client was taking a booking, they'd be changing screens all the time to try and put in all the information because you do things to do with the client and the actual booking itself, the time and so on, and other things like that. And instead of having that all there on one screen, they'd be jumping around. Oh, this is a known client. Where's their standard pickup address? I've got to jump over here. Very poor design and really unprofessional at many levels, and were not helpful in trying to fix it and so on. And yet they were bound to this developer in a way that I'll show you in a moment. And so they were paying money regularly to this developer to maintain the current system, which was unsatisfactory in many senses. So let's have a look at a deployment diagram to give you an idea what was going on. And I have to say, I talked to the client, talked to the company about the way they're operating, and they didn't know their system was like this, right? This was required investigation. They had no idea. From their point of view, the system's just one big thing. It's the behaviour that they see. They don't distinguish between hardware, software, networking, or whatever. So they don't know what's going on at all. So if you look at this, what you'll see is we've got some PCs running locally within the organisation. And what we've got is a server here, basically developer A's cloud, if you like, their server sitting off somewhere. The PCs in the organisation, they're running remote desktop. Are you familiar with what remote desktop is? Okay, that's Microsoft's tool for showing a desktop that's running somewhere else. So the workstations running in the chauffeured car company simply ran remote desktop. That's all they ran. So they were showing what's running elsewhere, not running something locally. So what was running on the server back here was a login session used by a particular operator. And that login session actually ran two different systems, the system that we've called V3 and a system called V5. V5 is the system I mentioned to you that was rewritten by developer A, and System 3 was an older system. So this was actually written in Visual Basic, this System V3, and this System V5 is written in C#.NET, so more current technology. So what's going on here? Well, from developer A's perspective, if they have control over everything here, and they just run remote desktop, they can make whatever changes they want locally here. They don't have to deploy anything out to the client site. They don't have to drive out there, install things. They don't even have to remote in and fiddle with configuration. So this is the easiest arrangement for them to use to maintain things. Now, the problem with this arrangement is that everything's going through remote desktop. So if you have any issues with internet, even your keystrokes aren't going to be echoed potentially while... and they noticed that, for example, if the accountant was downloading records or something through their accounting system, then all of a sudden these remote desktops would start behaving badly. So it was an appalling setup for this company. Why were they running these two versions of the system? For exactly the reason I mentioned to you earlier, which is that the version 5 system the way it took bookings was completely unusable for them. So they kept using an old version of the system, version 3, for taking bookings, and then did other things like managing client contact details and so on in version 5. And they could do that because version 5 had been written to share the same back-end database as version 3. So they'd had this system rewritten. The original system was old enough to be using Visual Basic on a SQL Server database. So the version of SQL that the database was written for was an old version and didn't use any data integrity or performance features that a more current version of SQL Server would use either, even though the system was rewritten. So this is kind of a horrible setup from the client's perspective. And it turned out they had networking problems that were hardware problems as well that impacted on the system. But all of these things combined together to cause all the problems that we've sort of talked about. So, yeah, remote desktop over internet to the remote server, sharing of limited bandwidth, the user interface freezes, can't do anything. So you can imagine if you had all the interface running locally, you could at least keep typing and so on and wait till the delay was over. You could keep entering into a form or something, but the way it was set up, you couldn't do anything if it freezed. The reliability of the interconnection was poor, and the connection would actually go down on occasion. So there are actually layers of things. The connection was unreliable, sometimes it was slow, sometimes it was loaded, and all these things just gave this picture of the system not being reliable. So they needed these two versions of the system, but one of them was in old technology that really they couldn't keep maintaining. They really had to get rid of that Visual Basic version of the system. But currently, for taking bookings, they really needed to keep using it. And everything was running at developer A's site. All the code was there, source code, everything. They had nothing. They just had these remote desktops going through. Okay, I think I've touched on those, though perhaps what I didn't say was the design of both V3 and V5 was generally poor and very highly coupled. So if you looked at the code, it was pretty awful, which does have implications for this next stage. So trying to resolve the problems for this client. Now, they have to keep using the system. It's essential for their business. They can't stop. And they need the problems solved fairly quickly. They're facing competition from Uber. They need to distinguish themselves. You know, what can we do? Because there's a time imperative to get something done. Well, one way of doing something quickly is a commercial off-the-shelf system. That's a way of getting something running quickly, generally a low starting cost, though you have a fixed overhead. Even if the business grows, that overhead's going to grow as well. And a problem for them was that their business was quite different in various ways that I'm not going to go into here. There's lots and lots. You'd be amazed at how many systems are out there off the shelf for chauffeured cars or taxi services and things like that. There's so many of them. But you analyse them, they tend to be have a fairly fixed model. And so this business had their own software, even with the problems of it. They had some flexibility. They could get minor changes made to suit themselves. They were reluctant to move in this direction. Another option is to rebuild. And I can tell you, when you talk to vendors, talk to software development organisations, that's what they always want to do. They don't want to touch some old system. Oh, we'll rewrite it for you from scratch. It'll only take us 6 months. So you can have nothing for 6 months, and then you can transition to a completely new system, retrain everyone, and so on. That's their solution. And you know, that's a way of managing a risk for them. But obviously there's a high cost and a long delay until it's available, so that's not necessarily ideal. Another choice is to find some way of modifying the existing system. So if you can modify it, then the transition is going to be easier for the current operators, for the business as a whole. But I can tell you, finding a developer who is going to look at that horrible code and say, yeah, I'll take that on and modify it in some way. Very few people are willing to do that, and the cost can be high, and you can still get delays in terms of dealing with it. Okay, I'll